Okay, so we're supposed to find the velocity, speed, and acceleration for this body at time t. Okay, so the velocity is just the first derivative. So when you take a derivative of this function, the derivative of a constant 0, and the derivative of negative 4 cosine t is 4 sine t. And that's because the derivative of cosine, what am I doing? The derivative of cosine is negative sine. So negative 4 makes a positive 4. So that's the velocity. The speed is just the absolute value of the velocity. So the speed is for absolute value of 4 sine t, because sine dips into the negatives, right? So this could be negative in some places, so we need the absolute value symbol. Okay, because if you're talking about speed, if you're going backwards 20 miles an hour, or if you're going forwards 20 miles an hour, your speed either way is 20 miles an hour. Okay, your velocity could be negative 20 because velocity depends on whether you're backing up or going forward. Okay. And so acceleration is just the second derivative. So I need to take a derivative of the derivative. The derivative of sine is cosine, so that's all we have to do for the second derivative. Okay, and then they want the velocity, speed, and acceleration at time t equals pi over 4 at a certain instant. Okay, so we want to plug in pi over 4 in for the derivative to find out its velocity. So if we do that, if you plug pi over 4 in here, then we need to figure out what sine pi over 4 is. So without a calculator, the way you do that, sine pi over 4, is you could draw the angle pi over 4. Because remember, the argument of a trig function is always an angle. So what goes inside the parentheses is always an angle. And pi over 4, the quick trick of converting that to a degree, if you want, is to cut out the pi and then multiply by 180. So 1/4 times 180, that's a 45-degree angle. So that's pi over 4 right there, 145 degrees. Remember, you rotate from the initial side to the terminal side. And then you draw a right triangle with the x-axis and label it. Okay, and it's always easiest if you draw it within the unit circle, because that means the hypotenuse is 1, and these values are known to be square root of 2 over 2 and square root of 2 over 2. You could use the Pythagorean theorem to find that, but if you have a 45-degree angle, the side measurements are square root of 2 over 2. So the opposite over the hypotenuse is square root of 2 over 2 for that triangle, right? And that's what sine, that's what sine 4 pi is. So it's 4 times square root of 2 over 2. Okay? Because sine 4 pi, sine pi over 4 is square root of 2 over 2. So 4 times sine 4 pi over 4 is this. And so the 4 and the 2 can cross cancel. You get 2 square roots of 2. Okay, the speed is just the absolute value, so the speed is still 2 square roots of 2. And if that was negative, we'd just change it to a positive. And then the acceleration would be when we plug in. So the acceleration at time t equals pi over 4, we just plug pi over 4 in for the acceleration. And we've already got that triangle drawn, right? Pi over 4, that's a 45-degree angle. Cosine's the adjacent divided by the hypotenuse. So cosine is square root of 2 over 2. So it's got the same speed, same number for the speed as the acceleration. They're different units, but that would be the acceleration.